Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's show is the search for extraterrestrial life. And here to talk about it is our guest, Dr. Timothy Dey.
Hi, Don. It's a pleasure to be here today.
Glad to have you back. We've done this topic in years past, but we've got more information.
We have, and recent more information, and of the most exciting kind. So let's start talking about it.
Absolutely. So what is the prerequisite for life as we know it?
You have to have water.
Now, liquid water, right?
It's got to be liquid water. Liquid water, it turns out, is really good at dissolving stuff. You can put all sorts of stuff, not olive oil, but most other things, salts and sugars and whatnot, they all dissolve in water just nice. And that's because water is what we call a very polar molecule. It's like a bar magnet. One side is really negative, the other side is really positive. And that's what we're looking at in this picture here. Look at the slide that's up there. You'll see that there's two H's. That stands for hydrogen. And you'll notice that there's that little weird snake-like thing. It's almost like a letter A, a number 8. And it's got a plus next to it. And that's because it's got a single positive charge. There's two hydrogens, there's two positive charges. And if you look at the oxygen, there's two negative charges. And what that does is it makes it a bar magnet. And that makes the water able to do a very special trick. It can stay liquid through a large range of temperatures, 100 degrees Celsius. Right? Mm-hmm. And then the other thing that makes it special is the fact that it can form ice that floats instead of sinks. Every other liquid, when it freezes, it goes down, it sinks. Water's ice goes up, and that's a good thing in the hunt for life, because what that means is when water freezes, it rises up and it forms an ice cap over whatever ocean it's sitting over, and it keeps all that water from bubbling away or freezing and sinking to the bottom in a big hurry. So all of those characteristics make water very, very special compared to other liquids.
So as NASA said years ago, follow the water?
Follow the water. That hasn't changed. It's not wrong. So I've beat this to death over every show we've done together, but it really does matter that much. Water makes all the difference. We have a slide of a periodic table. Let's see that for just 2 seconds. And there it is. And you'll notice that O for oxygen is all the way up at the top. And that makes it very, very powerful in terms of being negative. It makes it the strongest bar magnet that you can easily make with two hydrogens. You can do sulfur underneath it with two hydrogens or selenium or whatnot, but the lower you go, the less of a bar magnet it is. The ice doesn't float, it sinks, and also those things like to be very cold, well below freezing. Okay. And they have very narrow bands of being a liquid. They are they have maybe 20 degrees of range of being a liquid, whereas water has 100 degrees of range of being liquid. All those things make water exceptional, unique in our universe, and that's why we really think that if we find life, there's going to be water associated, and as you said, liquid water.
Liquid water, and we have water in our own solar system, both on Earth and at other planets as well.
We do indeed have water on Earth. And let's go ahead and show you some of the things that are happening in that water. So we have hydrothermal vents. Here's a picture of a hydrothermal vent. It's actually two right next to each other, and you can see these huge billowing smokers, black smokers they call them because it's so dark looking. This is a very deep sea sub. It's probably unmanned, and it's perhaps maybe 4 or 5 miles deep. And there's magma right underneath that, and it's almost to the surface, gets to the water level, and it freezes sort of. And you see these frozen spikes of earth, literally rock, and then all of this black stuff coming out from the magma just underneath, and it's nasty. It's hydrogen sulfide. It smells like eggs if you put it in a bottle and bring it up. It's just poisonous. It's toxic stuff, and yet life survives there, and maybe even started there on our planet. So if we go to the next slide, we see that there's all sorts of things coming out with these hydrothermal vents. You can see the water kind of boiling behind, but you'll see the word zinc and iron and hydrogen sulfide, which is the stinky stuff, copper, even gold is coming out of these vents from the magma underneath.
Interesting.
So it's a busy place, yeah. And to the left side, you can see, well, here's a great shot. Here we have tube worms that are forming up, and you can see the black smokers, right, all the way around. The tube worms are colorful, and they're white, and there's actually little crabs crawling around in those tube worms, and there's little shrimp-like creatures that crawl around with those tube worms. If we go to the next slide, you'll see a close-up. These are tube worms, and it's hard to tell the perspective because you got no scale. They get to be about 6 feet long and live, maybe they're guessing 2,000 years or so.
Is that right?
As long as their black smoker keeps providing energy to the system, yeah. And you can see these feathery gills there and whatnot. So this is life appearing on Earth in a crazy poisonous environment where when they discovered those, they were just like, are you kidding me? There's life down here next to these poisonous vents, you know, so deep under this much pressure and zero sunlight.
And life without the sun.
Life without the sun, that's a big deal. No photosynthesis driving all the animal life and that consumes it and so on and so forth. And so the next image I threw in is of Buddy, my cat. And the reason I put Buddy in there, you can see him, he's sleeping in the crook of my arms. He was sort of a Christmas save last year. He needed a home and he was sick. And one of the things I've done in life, and my wife has been just helping pets out. But the reason I put that in there is because life is precious. Life makes us who we are. Life can make us smile, right? And so it's not just about finding tube worms and bacteria on some foreign planet, you know, next to a hydrothermal vent. It's about what else is there higher up than that we might come across as well. If we never look, we won't find it.
Right. Now, there is water on several other bodies in our solar system.
There are 4 things in our solar system that have water. You can see on the slide here that one of them is Earth. Yeah, okay, that's an easy one. But since we've done our last show, there's now absolutely positively no doubt about it, oceans of water about 100 miles deep under Mars's crust. We'll talk about that in a minute. And there's a moon around Jupiter, at least one. We'll talk about one of them that has geysers shooting up into space, and that's called Europa. And that's exciting because we're sending a probe out there in a couple of months to be out there, and we'll talk more about that in detail. And then there's a moon around Saturn. It's called Enceladus. It also has geysers shooting out into space, and we think there's almost certainly an ocean to be found underneath that ice cap. So again, we're real glad that water forms an ice cap. It acts as a blanket, protects the water underneath.
Seals that water in.
Seals that water in. And if there's magma deeper down, and we'll talk about how that's possible on a moon so far away, then it's actually a heating element and a chemical lab. Throwing all sorts of stuff in there.
Interesting, interesting. Now, the thing about Mars has really got me intrigued because we knew that there was water ice at its north and south pole, and we suspected that there's some water just beneath the surface. We see those seeps from time to time, but now there's information about an ocean.
There is, and that water that you're talking about at the north and south poles is only there as frost. And a very thin layer of frost at that. It melts even at Mars temperatures, which are bitterly cold, in just a heartbeat. So it was like, okay, we're excited to actually find frost, but pools of water would have been nicer, you know, or pools of water with microbes in them would have been better yet. And so a couple of months ago, recently, they used a sound probe. Well, this is a cross section of Mars, and the artist has drawn in the water as blue. To retrieve this water would be sort of like fracking. So if we go to the next slide, you see an artist image of, here are a couple of things that haven't landed on Mars yet, but might, and then would drill down far enough to get to those water layers trapped between layers of rock. And we may well find signs of either former or present life there at a microbial level. We're talking small things. You know, we expect no more than that. You won't find my cat in there, all right? But it's exciting, right? So here's the actual proof. This isn't a pretty artist picture, an imagination. This is radar echoes that are strongly suggestive of those oceans that are flat and thin and underneath about 100 miles of rock, protecting it from having gotten blown away. Mars lost its atmosphere, and it lost its atmosphere because its core cooled. And when the core cooled, the magnetic field went away, and the magnetic field was protecting it from the sun's solar wind. No magnetic field, cool core, water evaporates into space.
That plus the fact that the atmosphere is too thin, you don't have enough vapor pressure to hold the water down. It just
entirely so
dissipates out.
Yeah, that's entirely true. That's right.
So we've got a couple of other moons in our solar system.
We do. Let's take the next one out. The one that's most exciting to us right now is called Europa, and there's a picture of it, a real picture, okay, from a previous probe that has flown around Jupiter and managed to capture pictures of all of the major moons there. This is really cool because the white is ice that you're looking at. Okay, it's not rock like when you look at our moon. And the ice has cracks in it all over the place. See all that brown? That brown is organic compound stuff. That's tar.
Okay.
All right. And the tar is filling in the cracks in the ice caused by what? Strong evidence that there's water underneath. There's the ice forming the blanket, right? Here's water's magic trick. Ice floats. That's the only thing that, you know, almost just the only thing that will float its ice instead of having the ice get heavier and sink. And what you begin to see is that there are plumes of heat underneath the ocean at the bottom of it, just like at the bottom of our ocean. And you got those hydrothermic vents spewing all these chemicals and heat energy and whatever else in there. Makes it a really rich soup. It's like broth, right?
Oh,
and
yeah.
then if you look at enough, you see water in this cross section bubbling up from, on the bottom left, you can see a red spot there.
Yep.
That's magma, right, coming up from inside of Europa. And then it boils the water just on the other side of it, black smokers. And then that rises up and it gets to the ice blanket that keeps the ocean in place. And then it pops through the ice at the weak spots and it spouts into space and it looks like a geyser. And we have seen the geysers for real. They're there. So we're sending out a satellite. It leaves November. Finally.
Yeah. It's been on the books for a while.
It's been on the books for, it was like the James Webb Telescope. How long can I wait, you know?
Exactly.
Finally it happened. So this is finally happening. And what they were being really careful about was when you send something to Jupiter, Jupiter has a lot of radiation around it, unlike our planet, fortunately, which has a nice protective magnetosphere to protect us from the solar particles of the sun. There's no such protection out here from particles from Jupiter. And so anything that visits, here's a great shot of the spacecraft's orbit. This is what it's going to do. You can see Europa is nice and circular, and Io is one even closer yet. It has geysers too, but they're volcanic geysers. And we can see them easily as well. We can see them with the James Webb. So if you would go back one slide again, let me just make a point about the orbit we saw. Right, so the spacecraft's representative orbit, that's bottom left, you'll notice it's like an egg and it's slanted way off to one side. And that's very deliberate. It would do a better job of taking pictures of Europa if it came right up close to Europa and stayed there. Why doesn't it? It would get fried. The radiation would cook it like an egg. Its electronics, the onboard computers, and other instruments, they would get cooked. And so we've had to send them up encased in a box of heavy protective stuff. All right. And there was concern, will this be enough to protect it? And the decision finally was, yeah. So they went ahead and they gave us this elliptical orbit. And that means that some of the time it's really close, 16 miles away. 50 different times it'll be 16 miles
They'll
away.
have a good opportunity to get a lot of
They
information.
will use radar, they will use mass spectrometers, they will use regular cameras, narrow and wide angle, most of the good toys
Right.
that people want to see.
Plus, I'm sure that they'll be trying to find some of these geysers to be able to read what's in it and determine if there's any type of microbial life.
There might even be a chance to fly through a geyser at some point. That would sort of be luck. The geysers come, the geysers go. You have to, plan to some extent, and you can't.
Well, that's it. That's it. This has been a really interesting first part of our discussion. We do have to take a quick break. Please send us an email, the address down there at the bottom of your screen. And coming up next with Term of the Month is Stephen.
Thanks, Don. The term of the month is mini-moon. A new mini-moon was captured into Earth orbit on September 29th and will be with us until November 25th. It's about 10 meters. It's called 2024 PT5 and is an asteroid captured from the Arjuna group. It's the 5th detected mini-moon. It won't be visible in small telescopes. It was found using the Asteroid Terrestrial Impact Last Alert System, or ATLAS, which is an ongoing project designed to search for asteroids near Earth. Astronomers have defined mini-moons as asteroids or comets that are gravitationally captured by a planet for a temporary amount of time. This one is a temporarily captured flyby, meaning it doesn't make a full orbit around Earth. Computer modeling suggests that Earth has at least one captured mini-moon under 1 meter in diameter at any point in time. There are lots of objects in the Arjuna group. These objects are hard to detect and are usually found by projects looking for asteroids near Earth. There are several projects which do this, including the Catalina Sky Survey, CSS, and the Spacewatch group. We can expect many new discoveries when the Vera C. Rubin Observatory's Legacy Survey of Space and Time, LSST, starts observing, expected in mid-2025. And that is the term of the month, mini-moon. Back to you, Don.
Thanks, Stephen. Welcome back. We're here with Dr. Timothy Dey talking about search for extraterrestrial life. Now, we've got one more stop in our solar system before we head out beyond.
We do. And it's a lot of people's favorite planet because it's so pretty. It's got rings. And we're talking, of course, about Saturn. Saturn has moons that are very large as well as Jupiter. And we are pretty sure that there is one of them called Enceladus. And here's an artist's picture of it on the screen. And you can see a geyser of water blowing through an ice cap of water, protecting it once again from the ravages of extreme cold and space and low pressure. You can see in this artist's rendition the rings of Saturn in the background, top left corner. Just letting you know, hey, we're looking at Enceladus. We're away from Jupiter now. This may be much the same story as we saw in Jupiter with Europa. So there are heat sources underneath. There's magma that we're pretty sure is bubbling away like the black smokers do on Earth and are probably doing on Europa. And they heat the water and the water rises and it hits that ice cap blanket. And in the weak spots, it shoots up into space just like we're seeing on Europa. This may actually be the more common place to look for liquid water in other solar systems than we thought at first important. There's one more picture of Enceladus here, and this is a real photograph taken by a probe that was called Cassini, after an important astronomer who came right after Galileo and spent a lot of time looking at Saturn and its rings. And so here you see this cool picture. You know, the sun is hitting the surface of Enceladus just right, and you can see those water jets just cranking out into space. We're about as excited as going to Enceladus as we currently are about going to Europa.
So we'll stay tuned on that.
Stay tuned for that, right?
Okay, so now we're going to head outside the solar system. What kind of tools are we going to use to?
Oh, that's a good question. A big, big, big telescope, and one that sees well into the infrared and darker red colors, not just the traditional colors of, say, Hubble.
Right. Hubble is visible and near infrared. We need an infrared telescope.
We need an infrared telescope.
And we just put one up.
We did at that. And it sees well into the red. And it sees things that would be invisible to us if you didn't have a telescope that was able to see through dust and dirt and all of the rest of this kind of stuff, and also didn't have just huge, huge mirrors to collect as much light as possible.
Of course, it's the James Webb Space
It
Telescope.
is the James Webb Telescope that we're talking about. Yeah, that's the instrument, one of the instruments. There are others that we will be using to look out. So here's an artist's rendition. The Earth is in the background. You can see a hint of the sun up above, and you get the idea of just how big the mirrors are. And then what's underneath it are not solar panels, they're shields from sunlight. And then the science instruments are sitting in the shade all the time. And they're cooled as low as we can make them go. And that makes the whole thing exquisitely sensitive to red light and infrared light.
And we're studying some of these solar systems beyond our own to find planets like Earth or moons like Enceladus or Europa?
Yeah, and so the question is, well, how do you know that there's signs of water? Remember, we're always looking for the water. And, well, it turns out now that the James Webb and other telescopes in orbit are so exquisitely sensitive that we've compiled a list of a growing list of potentially habitable exoplanet. An exoplanet just means not in our solar system, but it's definitely a planet, right? So you see this nice, there's an example of, Earth is in the upper right-hand corner. That gives you a size perspective compared to these others. So you can see most of them are bigger than Earth. There's one in the bottom, it's called Kepler. It's a bottom in the middle, and that's closer to our own Earth size, and we're very excited about exploring that.
Oh, for sure.
Yeah. So the way we do this is to, here's another one that's even better. TRAPPIST-1. Look at how many moons are in, or planets are in the Goldilocks zone. That's the sweet zone where we think water is likely to be liquid at least some of the time. And underneath it, in comparison, is our solar system. You see Mercury close to the sun, Mars, and then we stop because everything farther out than Mars is ice. Right. It's frozen, unless you're a special moon of one of the gas giants.
Well, now when we're looking for life in these exoplanets, we're looking for microbial life. We're not looking for...
We're looking for microbial life. We'd be very happy to find the right molecules, even, that say, it's not actually a microbe going, hi, you can see me in here. Instead, it's the things that molecules make.
Yeah.
And
in our last, I was just going to say, in our last minute, we've got this picture here, and then what about the future?
That last one was a spectrograph taken by the Webb telescope, and what we do is we peek through the atmosphere when it's briefly in front of its own sun, and we get this reports back. Oh, there's methane here, there's carbon dioxide here, there's more methane on the other side, there's dimethyl sulfoxide. You know, all of these molecules are associated. Is there directly water vapor there? No, we don't see that yet, but boy, I think we're getting close.
So we've got some stuff there for future scientists and future generations
I
to
would
follow up.
considering how fast things have changed between the last show and this one, I would expect a wonderful future for any scientist who goes into this field. It's rich, rich material, and it's changing rapidly. You know, there's great. It's a full career for anybody that wants to go that path.
This has been a fascinating conversation. I wish we had more than our half hour. I want to thank you, Dr. Tim, for being here to talk to us.
I enjoyed this.
Again.
Yeah, this is fun.
Please visit our club website. We like folks to check that out as well. And coming up to finish up the show, as always, is Stephen with What's Up.
Thanks, Don. What's up in the night sky for October 2024? We start just after the equinox, so the days are changing faster than usual. The month starts on the 2nd with a new moon. On the 10th, we have the first quarter. On the 17th, the moon is full, and on the 24th, we are at third quarter. Then we have really Venus and Mercury, but we're also going to talk about Pluto and Saturn a little bit. Mercury goes from Virgo to Libra, but it starts at the beginning of the month at superior conjunction, and at the end of the month, it sets at sunset plus an hour and a half, so it's better at the end of the month. In fact, all of these are. Venus goes from Libra, that's Libra again, to Ophiuchus, and sets from an hour after sunset to an hour and a half after sunset by the end of the month. So Pluto is shown, and it's really at a bright time of day, but really sunrise, 6 hours after, before sunrise, is a good time to look at Pluto, because you want dark skies because it's so faint. Remember, big scope, all of that stuff. Then we have Mars, Jupiter, Uranus, Neptune, and Saturn. Mars goes from Gemini to Cancer and rises around midnight all month. Jupiter is in Taurus and rises from 3.5 to 2 hours after sunset. Saturn is in Aquarius and sets an hour after, 2 hours before sunrise to 3 hours before sunrise. Uranus is also in Taurus, like Jupiter, and rises 3 hours after sunset to an hour after sunset. And then Neptune is in Pisces and rises from 2 hours after sunset to half an hour after sunset. So these are all better at the beginning of the month. And that's what's up in the night sky for October 2024. Now remember, we don't charge money for this show, but we may tax your brain.